Okay, today's lesson's about acceleration. Last time we looked at calculating speed and converting between units. Today we're going to be looking at the section of the syllabus that deals with acceleration. Before we start, let's just remind ourselves about the difference between speed and velocity. If you remember, speed is a scalar quantity. To define speed, we just need to use a number and the units meters per second or kilometers per hour. And so a speed of 20 meters per second gives us all the information that we need. Velocity, however, is a vector quantity, and a vector needs some indication of direction as well as speed. So for example, the velocity vector has a magnitude of 20 meters per second in our example, that's the speed, but if I say it's coming towards me, then I've specified a vector. I've given the size, 20 meters per second, and I've also given a direction. Directions, as we'll see today, don't have to be things like towards me or away from me. They can be positive or negative, as you'll see in today's examples, or they can be with respect to X or Y axes, or given in terms of directions or bearings. At GCSE, we'll often use the symbol V for both. We don't use the symbol S because at higher levels it actually means something quite different. So of course, if you see V and it's just got a number with the correct unit, so for example 200 meters per second or 10 kilometers per hour, then you know that you're just dealing with speed. If you see some indication of a direction, for example a sign or a statement about a direction or an angle, then you know that you're dealing with velocity as a vector. So, because velocity is a vector, you see quite shortly that acceleration is also another vector to add to your list. But what do we mean by acceleration? Well, if you go into a car showroom and the salesperson tells you that this shiny sports car has an acceleration of 0 to 60, or 60 kilometers an hour in 2 seconds, then you know that that car can travel from 0 kilometers per hour to 60 kilometers per hour over a very short period of time. If you're on your bike, then even if you could get up to 60 kilometers per hour, it would take you a lot longer to achieve that speed, so your acceleration would be less. So acceleration then is how quickly the speed or velocity is changing. And as I said, it's a vector, and we indicate its direction by saying the acceleration is increasing, in which case it's a positive number, or decreasing, in which case we'll have a negative number. So if we think of then as acceleration as the rate at which an object changes its velocity, that's a fairly good starting point as a definition. What's the equation then? Well, if velocity is the change in distance divided by the time, then, and acceleration is how quickly the velocity is changing, then we can write the acceleration equation as being the change in velocity divided by the total time taken. Remember, you can always work in word equations at GCSE level. However, for the more difficult, more challenging questions, you may find it useful to use the symbols. So in symbols, we write the change in velocity as v minus u. You could put brackets around that. V here means the final velocity. So in our car example, that was a 60 kilometers per hour. U is the initial velocity. So if something's starting from rest, and it doesn't have to, then U is quite often 0. T is time. Most cases you will be using the SI units of meters per second and seconds. So what units then should acceleration have? Well, we know that velocity or speed has the acceleration of meters per second, and it turns out that acceleration has the units of meters per second squared. So where does this come from? Well, if I just change to my little pen tool here, sorry about delay there, change to my little pen tool, we have meters per second, so that's our velocity, and we want to say how quickly that change in speed took place. So we're going to divide it, so change in velocity divided by the time taken. So I'm going to divide meters per second by seconds. Now, when we want to divide a fraction, one side here, this side here, isn't written in terms of a fraction. So exactly as if it was a whole number, I'm just going to say that s is the same as s over 1. Now, if you remember, if we want to divide fractions, we take the second fraction and we turn it upside down. We take the reciprocal and multiply it. So I'm going to do that now. So I'm saying that to calculate the acceleration, we're going to take meters per second and we're going to multiply it by the reciprocal of s over 1, which is, of course, 1 over s. Apologies there. So 1 over s. So m times 1 then just gives us m, and s times s gives us s squared. So our final units then for acceleration are meters per second squared. And there we have it. The units of acceleration are meters per second squared. If you want to use a triangle, you can use the one I've shown here until you gain more confidence in rearranging equations. You will often see the change in velocity, as I said before, just written as change in speed. And as usual, you put your finger over the thing that you're trying to solve for and then use the remaining two parts of the triangle to rearrange your equation. Here we've got our first example. So we've got a car speeding up from 10 meters per second to 25 meters per second in 5 seconds, and we want to know what its acceleration. Well, as you have an equation for acceleration, then you know instantly that you don't have to rearrange it. So have a go at that and then restart this when you have completed that example. Okay, so using the equation then, the change in velocity here, well, we've got an initial velocity of 10 meters per second, so that's our u value, and we have a final velocity of 25 meters per second. And so our change in velocity then is, let me just move this down a bit, is 15 meters per second, and our acceleration therefore is 3 meters per second squared. In the next example, once again you're calculating the acceleration of a rocket that's changing speed or velocity from 200 meters per second to 2,500 meters per second in 6 seconds. So once again, setting out the problem properly, have a go at this example and then come back and see how you did. So once again, using the equation, acceleration is change in velocity over time taken, we can see that our change in velocity, so our final velocity is 2,500 meters per second, so that's our v. Our initial velocity is 200, so our change in velocity, which you could probably do in your head, is 2,300 meters per second. And so slotting that into our equation gives us an acceleration of 383.3 meters per second squared. Now the next example has got something of a sting in the tail of it, really. Once again, we're going to be calculating the acceleration, but notice the question asks you to calculate the deceleration. Have a go at this question, and then we'll talk about why I said there is a slight trick with this question. So set it out properly and then come back in when you're ready to check the answer. Well, once again, we need to calculate the change in velocity, v minus u. So here, we've got something slightly different. Our final velocity is rest. It goes to rest. So that means our final velocity v is 0 meters per second. And our initial velocity, because it's slowing down, was 28 meters per second. So v minus u gives you a negative number of minus 28 meters per second. So our acceleration is minus 28 meters per second divided by 4 seconds. So our acceleration is minus 7 meters per second squared. Now, if you left it like this in an exam, that would be perfectly acceptable. Acceleration is a vector. In this case, the car is slowing down, so the acceleration vector, the direction, is negative. And you'll see that when we come to look at accelerations on graphs. And so minus 7 meters per second squared as an acceleration is a perfectly good answer. However, there was a little twist with this question. So to answer the question strictly correctly, we need to know that deceleration is another word for a negative acceleration. So if we really wanted to be very strict about this, we should give the final answer as 7 meters per second squared. One word of warning though, make sure that you show all your working and at some point you've shown that your acceleration is negative. That way, if you have got confused with the terminology, you're still likely to gain full marks. Example 4 is a slightly more difficult question because we're already given the acceleration. So that tells you right away that you need to rearrange this equation. So what have you got? Well, you've got A, you've got T, because you've got 4 seconds, so you're actually trying to calculate V minus U, the change in speed or the velocity change. So have a go at using the triangle or rearranging the equation and then come back and check your answer. Okay, well, if we rearrange this equation, we can rewrite it as change in velocity as acceleration times time. So the change in velocity then is 30 meters per second squared and the time is 4 seconds. So our change in velocity is 120 meters per second. Notice the units here, meters per second. Now, what you could do if you didn't have I'm going to use a big thick pen probably here. If you didn't have your triangle with you and you didn't feel very confident about rearranging this, you could just put in the numbers into the original equation. So have a go at using that method, putting the numbers into the original equation, and sometimes you can easily see what it is you need to do to get the